Hello dear students of class 8, this is Priyanka Upadhyay, your physics teacher, and today in this video we are going to learn our fourth chapter, that is energy, from ICSE class 8 textbook. So what will we learn in this chapter? In this chapter we are going to learn the meaning of work, the measurement of work, units of work, meaning of energy, units of energy, power and its unit, forms of energy, conservation of energy, and transformation of energy. Okay, so in the beginning, we will study what is work. Okay, see here, the word work is commonly used in our daily conversation in connection with different activities we do every day. If you ask a person what is work, you will probably be told that it is the expenditure of one's stored up energy in the body. So, when you're thinking, studying, waiting for your friend at some place, or standing in a queue to get on a bus, you're supposed to be doing work. But in science, in physics, work done is defined differently. It has some different meaning. Work is said to be done only when the force is acting on a body and the body moves through some distance. Okay, so basically, when you say I have done a work, it means you're applying force on a body and you're displacing the body through some distance. Here in this figure, you can see that there is a constant force acting on this block. Okay, there is a constant force acting on this block. So if this is the position of initial position A of the body, and after the application of force, what happens? The body moves through some distance and it will come at B. So here in this case, we can say that the work is done. Okay. So when you're studying, thinking, or waiting for your friend, you're not moving any object or you're not displacing the object. So in this case, it means you're not doing any work. But when you lift your school bag, you do work because you are displacing your school bag from one place to another place. Similarly, if you apply all your strength and try to push the wall, what happens? The wall will not move. In this case also, the work will not be done because there is no displacement of the wall. So, to do the work, there are two conditions. First one is you should apply force on the body and the body should move. The body object should displace. Okay, so this is about work. So to do the work, there must be force which acts on the object and there must be motion of the object in the direction of the application of force. Okay, so in the next okay okay so we will go to the definition of work. So in physics, work means more than something that requires physical or mental effort. See, work is done on object when force causes a displacement of the object. If the force is not causing displacement of the object, then we cannot say that the work is done. Okay, so work is the product of force applied to to an object and the displacement of the object. So work done is given by the formula force into displacement. And the amount of work done depends upon how will we measure work. Okay, this amount of work done, it is dependent upon the magnitude of the force. It means how much force you are applying, amount of force which you have applied on the body. And second one, the distance of the object along the direction of the force, the distance of the object along the direction of force. Here you can see that person is applying force on the box and he is displacing the box. So how much force he is applying? He is applying 10 newtons of force and the box is moving through 2 meter distance. So in this case, force is 10 newton and displacement is 2 meters. Therefore, the work done is F into S. Force is how much? 10 into 2, that will be 20 Newton meter. Okay, so work done will be 20 Newton meter. Next. So what are the units of work? See here. We know that work is equal to force into displacement. So the unit of force is Newton and unit of displacement is meter. Hence, the unit of work will become Newton meter. I will just show you that how it will be. See here. Unit of force. Unit of force is Newton. Okay. Into unit of displacement is meter. Therefore, the unit of work is Newton meter. This Newton meter is called as joule. Henceforth, whenever we use work, we will express it in terms of joule. Okay. So 1 joule of work is done when the point of application of force of 1 Newton displaces a body through distance 1 meter. It means you are applying 1 Newtons of force and the body is moving through 1 meter distance, then we can say that 1 joule of work is done. So now we will go to energy. So what is energy? So usually we say that we have energy. Okay, I have energy to do that. I have energy to do this. So what is energy? Energy is the capacity to do the work. The SI unit of energy is joule. CGS unit of energy is erg. There are some other units of energy also. See here, the heat energy is measured in terms of calories. 1 calorie is the heat energy required to raise the temperature of 1 gram of water by 1 degree Celsius. How heat energy is measured? Heat is a form of energy. Therefore, it is measured in terms of calories. So, what is 1 calorie? 1 calorie is the amount of heat energy which is required to raise the temperature of 1 gram of water by 1 degree Celsius. Okay, so there is a relationship between SI unit and SI unit, that is joule, and CGS unit, that is earth. So what is that relationship? 1 joule is equal to 10 raised to 7 earth. 1 joule is equal to 10 raised to 7 earth. Okay. Okay, just a minute. So now next we will study about power. So how will we define power? Power is defined as the rate of Power is defined as the rate of doing work. Here, it is the amount of work done per second. Whatever the work you are doing in a second, per second, it is known as power. So the amount of work done by you in 1 second is power, and the unit of power is joule per second, because work done per second, it means power will be written as, here you can see power is W divided by T. Okay, therefore the unit of work done is what? Unit of work done is joule and unit of time is second. So therefore unit of power is joule per second. Here you can see unit of power is joule per second. Larger units of power are kilowatt, megawatt and gigawatt. Commonly used unit of power is horsepower. 1 horsepower is equal to 746 watt. 1 horsepower is equal to 746 watt. Okay, so let's go to the differences between, let's go to the differences between, sorry, energy and power. So, what are the differences between energy and power? Energy is the capacity to do the work, and power is the rate of doing work. Energy does not depend upon time, but power is dependent upon time. The unit of energy is joule and the unit of power is watt. Although it is joule per second, we will express that joule per second in terms of watt. So the unit of power is watt. Now, we will study about the forms of energy. So in nature, we have many forms of energy. So here we will learn about mechanical energy. This mechanical energy is basically made up of kinetic energy and potential energy. Next, we will study about heat energy, light energy, electrical energy, magnetic energy, chemical energy, sound energy, and finally nuclear energy. So now, what is mechanical energy? In the beginning, we will study about mechanical energy. Mechanical energy is the energy possessed by a body due to its position, configuration, or state of motion. Here, if the object is having energy due to its position, changed position, or due to its configuration, or due to its state of motion, then the energy is known as mechanical energy. So this mechanical energy is basically is of two types. Okay, so that is two forms. One is potential energy and another one is kinetic energy. In the beginning, we will study about kinetic energy. Here, a moving hammer does work when it strikes a nail. Similarly, when a bullet is fired, it penetrates a thick wall. In each case, the object in motion has the ability to do the work and therefore it possesses some amount of energy. This energy is called kinetic energy of the body. So basically, kinetic energy is the energy that objects possess due to their motion. Due to the motion, if the objects are getting energy, that kind of energy is known as kinetic energy. So kinetic energy is given by the formula half mv square, where m is the mass, v is the velocity, and Ke is the kinetic energy. Mass is measured in terms of kilogram, velocity is measured in terms of meter per second, and kinetic energy, it is measured in terms of joules. So we will go through the examples of kinetic energy. Shooting a rubber band. When you shoot a rubber band, the rubber band will come in motion, and that moving object possesses kinetic energy. Water falling over the fall. Water falling over the fall, if we consider, so what happens? The falling water is in motion, and due to the motion, water possesses some energy, and that energy is known as kinetic energy. Third one, a yo-yo in motion. A yo-yo, when it is in motion, you might have played yo-yo. So when the yo-yo is in motion, what happens? It possesses kinetic energy. So fourth example is releasing the arrow from the bow. When you release an arrow from the bow, what happens? The arrow will come into motion. So that time in motion, it possesses kinetic energy. So next one, we have potential energy. Okay. So before learning, uh, before going to learn potential energy, we will just go through this kinetic energy. So what happens when the kinetic energy increases? When we say that the kinetic energy is increasing, it means either the mass is increasing or the velocity is increasing. If the mass of the object increases, kinetic energy increases. If the velocity of the object increases, kinetic energy increases. So now we will go to potential energy. See here, potential energy is the energy stored in a body or a system as a result of its position, shape, or change in configuration. For example, a stretched rubber band, a raised hammer, and a book on the table, they all possess potential energy. All these bodies change their form and regain their original form on removing the applied force. They have their energy stored in them that helps them to regain their original form. Okay, so what happens? Potential energy, which is the stored energy in the object. So here we can see some examples of potential energy. Stretching a rubber band. A rubber band in a stretched condition possesses potential energy because there is a change in the shape and size of the rubber band. So it possesses potential energy. Water at the top of waterfall, or we can consider water at the top of dam. So water at the top of dam is at rest. So due to the rest position, water possesses some energy, and that energy is known as potential energy. A yo-yo held in hand. A yo-yo, before releasing yo-yo, which is held, okay, in this condition, what happens? It possesses some energy, and that is potential energy. Last one is drawing a bow. See here, when you draw a bow, what happens? Due to the changed shape of the bow, it possesses some energy, and that is known as potential energy. So next, in potential energy, we have two types. So before that, we will study how potential energy is measured. Potential energy is measured by the formula PE is equal to mgh, where m is the mass of the object, g is the acceleration due to gravity, and h is the height to which it is raised. Okay, so now we have two types of potential energy. One is gravitational potential energy and another one is elastic potential energy. Gravitational potential energy is the energy stored in an object due to its position above the earth's surface. For example, you can take any object beside you and just raise it to some height. So in that raised position, it possesses some energy, and that energy is known as gravitational potential energy. And gravitational potential energy is given by the formula mgh, where m is the mass, g is the acceleration due to gravity, and h is the height of the object, where here ep represents the gravitational potential energy. Next, we have elastic potential energy. See, elastic potential energy is the energy stored as a result of deformation of an elastic object. For example, the stretching of a spring. So when we stretch a spring, what happens? It possesses some energy, that is the stored energy. Okay, so that is known as elastic potential energy, and this elastic potential energy is always a stored energy in the body. However, potential energy itself is the stored energy. Some more examples are when you stretch a rubber band. When you stretch a rubber band, what happens? It possesses some energy due to the stretched condition, and that is elastic potential energy. When you compress a spring, due to the application of force, it stores some energy in the body, and that is known as elastic potential energy. Next, we will study about the kinetic energy and potential energy using simple pendulum. See here, This figure shows a simple pendulum suspended from O. See here. This is, if we consider this as O, so what happens? It is suspended here. The resting position. So this is the resting position. I'll just show you. So this one is the point of suspension. So I will name it as O. And this is the resting position. This is the resting position and I will name it as B. Okay. So here, this position I will name it as A, and this extreme position I will name it as C. Okay. So the figure shows a simple pendulum suspended from point O. The resting position is B, the mean position. Resting position B is nothing but the mean position. When the pendulum is made to swing from one side to another side, that is from A to C. From A to C. What happens? It covers equal distance on either side and gains equal height. So it covers equal distance on either side and it gains equal height on both the sides. So let's study about the energy possessed in different position. So at A, what happens? So at this condition, what happens to energy? So here the potential energy will be maximum. At this condition, at position A, the potential energy will be maximum and the kinetic energy will be zero. Here at B, what happens? The potential energy will be zero and kinetic energy will be maximum. See here, because it is moving from one end to another end. So at maximum position, the bob comes to rest. So in this case, at A position, potential energy will be maximum. So what happens? It converts into kinetic energy. So here at this position, it gets maximum kinetic energy and potential energy will become zero. And again, as it moves forward and as it reaches the another end C, again the potential energy will become maximum and kinetic energy will become equal to zero. Okay. Otherwise, here in between we can say that here we can say that potential energy and kinetic energies are equal. And here it is observed that when the bob swings, that the bob has only potential energy at its two extreme points, that is A and C, and only kinetic energy at resting position. In between A and B, B and C, the bob has both kinetic and potential energy. The swinging of a pendulum also demonstrates that the total mechanical energy remains same, that is conserved. So here what happens in each case, the potential energy is converting into kinetic energy or the kinetic energy is converting into potential energy. So what happens? So the energy is conserved in this case. Okay. So next we will study about, just a minute. Okay. So next we will study about the forms of energy. So there are forms of energy. See here. Nuclear energy, mechanical energy, potential energy, kinetic energy, heat energy, light energy, chemical energy, electrical energy, and sound energy. So here we will not study about these energies because it is excluded from the syllabus. So we will go to law of conservation of energy. We will go to law of conservation of energy. The principle of conservation of energy states that energy can neither be created nor be destroyed. The total energy of the universe remain constant. Neither you can create the energy nor you can destroy, but the total energy, it always remains constant. Energy can be only transformed from one form to another form. See here. energy. You cannot create or destroy energy. Only we can do is we can convert it from one form to another form. So transformation. So now we will study about the transformation of energy. So what is transformation of energy? What happens here? See here, in transformation of energy, one form of energy is getting converted into another form of energy, because as we know that we cannot create or we cannot destroy energy. So what we will do, we will just, so what is happening, energy is converting from one form to another form. So we will study about those. First one is electrical energy is converted into sound energy. Examples: loudspeaker, electric bell and stereo system are some of the many electrical appliances that convert electrical energy into sound energy. Second one, heat energy into electrical energy. Thermocouple, thermoelectric power stations are, are the examples which convert heat energy into electrical energy. Next one we have solar energy into heat energy. See here, solar cooker is the best example which converts solar energy into heat energy. So next one is electrical energy to heat energy. Electric heater, electric iron, room heaters, geysers, toasters, they convert electrical energy into heat energy. Fifth one, electrical energy into mechanical energy. See, conversion of electric energy into mechanical. It may be potential or it may be kinetic. See, table fan, washing machine, okay, mixer, grinder. In all these cases, what we are doing, we are converting electrical energy into mechanical energy. Next, electrical energy into light energy. Tubes, bulbs are the examples where what we are doing, we are converting electrical energy into light energy. Next one, we have light energy into electrical energy. Photocell is an example that converts light energy into electrical energy. Photocell or solar cell, which converts light energy into electrical energy. Next one, we have electrical energy into chemical energy. See, when we charge a battery, what happens? The electrical energy is converted into chemical energy, and which is stored in the form of battery. In battery, the electrical energy is stored, okay, in form of chemical energy. So next one is chemical energy into electrical energy. So what happens when you charge, the electrical energy is converted into chemical energy. But when the battery discharges, what happens? Chemical energy is converted into electrical energy. Next, we have mechanical energy into electrical energy. See, a dynamo is a device that converts mechanical energy into electrical energy. Chemical energy into heat energy. So we know that on burning fuels such as coal, petrol, diesel, LPG, CNG, fireworks, what happens? They convert chemical energy. So there will be chemical in these materials. So that chemical energy is converted into heat energy. Next, we have chemical energy into mechanical energy. See, in automobiles, what happens? The chemical energy of petrol or diesel, which transforms, okay, which helps to convert chemical energy to mechanical energy. Here mechanical energy is nothing but moving of a vehicle or running of a vehicle. Next we have light energy into chemical energy. See, uh, plants get a light energy, okay, from sun, and they prepare their food themselves. So in photosynthesis, what happens? Plants prepare their food using light energy, and that light energy is stored in them in the form of chemical energy. Next, we have sound energy into electrical energy. Microphones convert sound energy into electrical energy. Next, we have heat energy into mechanical energy. So, the steam engine. In steam engine, what happens? The heat energy is converted to mechanical energy. So, these are the transformations of energy. So, here we finish with our fourth chapter, energy. Thank you children. Take care. Bye bye.